Hi everyone, my name is Rebecca Stuchitz. I'll be your host today. I'm a part of the marketing team over here at Tech30. I would like to thank all of you for attending this webinar. And today we have Paul Dye, who will be giving a live presentation on topology optimization with Creo 6. We also have Ron Zabilski, who is a solutions consultant for Tech30. And just to remind everyone, if you have a question at any time during this webinar, feel free to drop it in the question or chat box, and we will do our best to answer these questions at the end of the webinar. With that being said, I'm going to be passing it over to Ron, who will give us a little background of who Tech30 is and what we have to offer.
Thank you, Rebecca. As we conduct this webinar, I encourage all of you to engage with us. You'll be able to ask the questions, as Rebecca said, leave comments in the sidebar on the GoToWebinar panel. And even if you have questions or comments that don't relate to today's specific topic, feel free to ask them, and we can address them in follow-up emails or in future webinars. And please view Tech30 as a conduit to get feedback to the PTC Creo product managers and development team. We'll also be happy to receive your comments and questions by email anytime after the webinar. So I just want to also let you know that for those that can take advantage of a PTC promotion that they're having now through the end of the year, you can get a Creo license or 2 Creo licenses from a buy one, get one half off pricing promotion. It provides you with 25% off of 2 licenses of Creo. This promotion is good for any number of 2 pairs of licenses through the end of the year. So please contact me if you have any interest in adding licenses to your environment. As Rebecca had said, my name is Ron Zabilski. I'm a solutions consultant with Tech30. First of all, Tech30 is a value-added reseller of PTC software products. Second, Tech30 is an engineering services company that helps engineering companies do engineering. We do this through the tools from PTC and other OEMs to help our customers make the most of those tools through training and engineering services. We strive to get to know you and your business, and we are at our best when we can actually expand the business of our customers to build up a community by connecting them with those who may be able to benefit from networking with each other. Next. The company was established in 2002, and we currently have over 80 employees with more than 50 engineers. Our headquarters is in Mission Viejo, California, but we're distributed around the United States, meeting the needs of our customers. I'm located in the Boston, Massachusetts area, and Tech30 has small business status and 4 business units. The business units are, first of all, the PTC software. We also represent a number of 3D printing and additive manufacturing companies. We do engineering services, and we also have a Siemens software arm. We can provide a wide range of engineering services, including mechanical and electrical design, static, dynamic, and kinematic analysis, design for manufacturing, assembly, and 3D additive manufacturing. We conduct new PLM implementations, system integrations, and migrations, as well as training services for all the above. Tech30 can provide services in areas of your engineering and design where you currently do not have the expertise, or supplement your existing in-house capabilities. Next. As a value-added reseller of PTC software products, we focus on these products, Creo, of course, Windchill, MathCAD, ThingWorx, and Vuforia. Next. As I said, we also have a broad portfolio of 3D printing companies that we represent. You can take a look at these technologies on this page, and I won't go into a lot of detail here, but just keep in mind that we focus on industrial cases for 3D printing, both in plastics and metals. We help our customers make additive manufacturing become part of their finished product, or to use it for tooling, fixtures, and jigs. Again, if you have any interest in this area, please contact me afterwards, and we can have a conversation about your use cases. Next. So, building upon these 3 points that Aberdeen Group had brought up, let's take a look at how Creo can help you. First of all, Creo can help you accelerate your product innovation without the worry of complexity. With Creo Unite technology, it helps companies have a competitive advantage in product innovation. We also help have greater reuse of the design data by helping you increase the number of innovations and faster time to market. And last, we're going to help you replace the design assumptions with facts by improving this new product design by creating new smart connected products. We do this ensuring that you, our Tech 30 customer, never compromise on your process, period. Next. So Creo allows you to get ready for the new world with the smart connected products. Creo is the only CAD tool out there with IoT and AR at its core, so you never have to compromise about designing smarter. With this webinar, Paul will go over the capabilities of Creo topology optimization and show how it can help you explore more design iterations. With that, it's all yours, Paul.
Okay, thank you very much, Ron. And my name is Paul Dye. I'm an applications engineer with PTC, and today I am going to be going over an overview of what we're working with Creo's topology optimization tool. So first, before we dive into talking about the tool itself, I want to take a step back and talk about some of the challenges that we see out in the industry and maybe some of the ones that you're facing in your systems right now. Right, so CAD and Creo specifically can give you good designs. So take what you're working with, what loads you have, and what you need to do, and you can build out a good part. And you can then take that to the next step and then run it through simulation to get an even better part and move some things around, cut some holes, make some rounds, and run the simulation to make sure everything's still good. But what if you want to get the best possible part? So whatever your requirement happens to be, least material, strongest part, how do you get there? And that's what we look to solve with Creo through specifically the topology optimization tool. So start with a basic part and take whatever your requirements might be and let the system build me out a manufacturable part that's optimized to exactly what I need in a way that I probably would not have thought of on my own. This is simply an extension that we can utilize in Creo. It's going to go through and follow the same workflow and interface similar to what we're already used to working with Creo Parametric, especially if you've used any tools like simulation or the Creo Simulate module. And it's going to start off in a similar way where we're laying out some structural parameters such as applied loads and constraints. If you already have these laid out in something like a Simulate study, you can simply reuse those and run the optimization with that as well. But the difference here is now we're going through and defining the geometry information of our part and telling the system which areas should or shouldn't be excluded from this study and which spots we shouldn't be optimizing on. At the same time, we're defining the area that we do want that topology optimization to be taking place in. On top of this, we're able to put in some fabrication constraints. So going into the study, we may know the machining processes that we want to use for this. So with this function, we can lay out right in the study some of these shapes that we want to stay consistent depending on the process that we're going to be going through. So we have some for castings, extrusions, radial constraints, mirrored and symmetric features. So not only building out that optimized part, but doing it with these fabrication constraints in mind. Once we have these laid out, we can run through the study, which is very fast, and then we have a lot of information going forward. So we can see the results, taking into account what I told the system to optimize, what not to change. Got some pretty complex geometry that may also be minimized for mass, anything that I might need or may have laid out in my study. So here's something that really only Creo has the ability to do. It's really take that tessellated, non-usable geometry and then convert it into something manufacturable. So other systems might be able to build out those simulated bodies, but those are really just guides for the user to follow because it was built out in a way that just simply wouldn't be possible to machine. Well, here in Creo, we're building it out as a freestyle feature. And this means that we're not only able to manufacture it, but we can go through and tweak the design and finally design a part that includes everything that I need and is possible to create in the real world. And working with Creo 6.0 in particular, we can now optimize components in the context of the assembly. So before we can only do that for the single part by itself, we'll now run that in the context of some adjacent geometry to really understand how that part is working. We're not only improving how we're running the optimization, but also how we're able to view the results of the study. So improve the animation, so really get those results, greater control around that animation, and more tools to edit the resulting geometries that we get. And after I have the results, how do I parametrically build out this part. I can also now specify exactly how I want to regenerate the geometry, whereas before I could just only have that freestyle surface. When I can use facets to move some of the spacing of nodes around, which really allows me to define the level of detail that I want with my part. And now we can move over into our Creo interface and see a little bit more about what this process looks like. Okay, so here we're going to be working with a Polaris Snowmobile data set. So with this, we have a lot of great geometry that we can utilize. Specifically, we want to take a closer look into our swing arm assembly. So let's open that up and see what we have going on. Okay, we can see there's definitely a lot of different parts and different features working together here, but maybe overall, I decided that there's just too much material being wasted. So I need to find a way to optimize on this design, but still adhere to my design criteria. And to do that, we're going to utilize the topology optimization extension in Creo. So I'm going to close out of that whole assembly and then simply go in and grab the part that we're going to be working with here today. Okay, here I have more of a blocky design for this assembly with some area built out that we can utilize for the study right there in the middle. And all I have to do is click up on my ribbon and find the topology optimization button and dive right in. The first thing we'll notice here is that I have some structural parameters laid out here, things like loads and constraints. And we're able to either lay these out at the beginning of the study, or again, take them from another study done in something such as Creo Simulate. If we already have them laid out over there, just bring them on in. And the next thing that we're going to do is define the type of analysis that we want to run. So this could be modal or thermal. In this case, I want to do a structural analysis using the loads and constraints that I already have laid out. And after this, we'll want to define our topology regions. So this begins by stating our mass fraction, what we want to get down to, and then defining which areas need to be excluded from the optimization study. So we know on our part that we don't want these bars or these holes being altered, so we'll tell the system to leave those areas alone. And then next, we'll be able to utilize our fabrication constraints. And again, that's what we're using for our different manufacturing processes. And so for my study, I want the optimization to be mirrored about a certain plane. And once this is complete, then I can start to define my design objectives. So we want to optimize for strain energy using the analysis, loads, and fixtures that we laid out earlier. On top of this, we can also lay out some design constraints. In this case, we don't want that mass fraction of our part going above 0.3. And now the last thing I want to do before running the optimization is defining the element mesh for our model. And though we could go through and define that ourselves, we can just simply let the system automatically build out that mesh for us. Okay, and now we have that all laid out. We have the criteria and the definitions for our study, so we can just go through, select the things that we defined, and we're ready to jump into our topology optimization. All right, so now what's happening is the system is taking in all those different things that we laid out between design objectives, mass limitations, fabrication constraints, and now it's building towards the optimal design that fits everything that we want it to accomplish. And once the system has gone through and built out those different iterations and converged onto a solution, we just simply have to close out and we can review the results right on the model. Okay, so we can very clearly see that this model has gone through a lot of different changes. And with Creo 6.0, we can actually animate those changes to see how the system got to where we are now. We're also able to save that animation off and use it anywhere else we might need to. Another cool feature that was introduced with Creo 6.0 was the ability to use ISO surfaces. So here we can see that optimized part, maybe against the boundary box that was laid out for it also, along with any types of stress values plotted out right on the model itself. So here on our model, we can see some of those resulting stresses at that joint. We can also look at the deformed view of our model, and then we can compare it alongside with the undeformed version to see how it's changed. We also have options to change how exaggerated that deformation appears to us and lower or raise it as needed. Okay, now that I've had time to review the results of my topology optimization study, I now need to get this into a form that I'm able to actually fabricate or machine. And I have options to define how detailed that I want that reconstruction to be. And so I can say I want that to be detailed, and then we can begin to build out a freestyle feature that I can actually work with. Again, Creo is the only software that allows you to take it beyond just that initial visualization that you'd be working with and building out your design. Actually lets us create that part that we've gone through and optimized. So now here I can go through, start to check out my model and clean up any areas that I see fit. I can take any of these faces and maybe go in and refine the facets to further mirror the part that I'm trying to build out. Okay, that looks good. And now that I've refined these facets, we can use some freestyle geometry that we have, and we can begin to reconstruct to match it up a bit. And again, with this tool, we have full control over what we want to define as the resolution for these features, and again, how closely we want them to be aligned. Okay, now that I've built out my model using topology optimization, maybe I want to share this design out with other people on my team. So this is something we actually began building out with Creo 4, the idea of incorporating augmented reality into our designs. So setting this up is extremely easy, and this box that we're putting in here is a spatial target, which is essentially going to act as the surface that my model will sit on, and the orientation and how I'll be able to view it. And then we can enter in our password here. You have this protected so only the right people are seeing this. And there's a few options regarding the quality that I want to publish this out as, and just like that, I can share the design. So now it's been pushed up into the cloud. We can share this off with anyone that I need to, and even password protected to make sure only the right people are seeing my models. And with Creo, we've really streamlined the process of sharing off our parts. So rather than having to send it off to individual emails, and we can just simply export to 15 or 20 people and can do that right from Creo. All right, so now that we've laid out our design criteria, run through the topology optimization, and shared that design off with members of my team, well, now I want to simulate the part to really truly get to that best design. So now let's open up that model and we put through our optimization, and we can move right over into our simulate module. And then we can again see those same loads and constraints that we had laid out earlier. We can simply utilize these to run a standard static analysis on my model. We can take a look at things such as stress values or displacement, whatever I have to be concerned with, and go through edit a few options, really laying out how I want that deformation to appear in my model. Okay, now we can see these results where the stress is occurring on our model, and different values laid out in the legend. What I want to do is compare these values and stresses that we're getting here to my original model, see if the changes that we made actually had an effect on the study. So simply looking at the max stress that we're getting on each of these, we're going from 607 megapascals down to 569 megapascals. So pretty significant drop off. And zooming in on this joint here, we can see also that our optimized model does a much better job of spreading out that stress rather than having it focus in on a very small area like the original part had. So that's topology optimization in Creo, where we're really creating complex and robust geometry that probably couldn't have come up with on our own, and moving forward with that. And so again, whenever now that we're working with the topology optimization in our systems, we're really able to start to automate and speed up a lot of the processes that would really have taken us a lot of time otherwise. And I just simply need to lay out a basic part, define some of my goals and criteria, and have the system build me out the best possible part. We can now define exactly what we want the optimization to focus on, whether that might be minimizing on the material being used or improving the overall performance of the part, or maybe even both. And if we need to go back later on and change any loads or constraints, or we just simply tell the system to run through another study, we can see now exactly how some of that geometry has changed and maybe some that has possibly stayed the same. On top of this, we're able to build out designs that we probably never would have been able to come up with just simply on our own. It's really breakthrough in the way that we see design today and the way that we approach our designs going forward. And so that's really all I have to show in terms of working with the topology optimization in Creo. And so I'll hand it back over now to Ron, and we can go into fielding any questions or wrapping up for today.
Thanks, Paul. So we actually have one question from Bethany Runyon so far, and it is, in what situations would you want to use a tool like topology optimization?
So the topology optimization is especially useful in things like concept generation portion of the design process. So whenever you're coming up with ideas that you probably really wouldn't have come up with just sitting there going through different iterations, really giving you new ideas about how you can build out designs. And in years past, topology optimization wasn't as useful maybe for parts that had to be manufactured because the geometry that you're working with just really simply couldn't be created. But now we have tools like additive manufacturing, where we can 3D print parts designed in topology optimization, or even use those features like we saw with the fabrication constraints for other different manufacturing styles.
Okay, great. Thank you. We also have one more question from Alex McNabb, and it is, are there different package options depending on the level of analysis that the user needs to run?
So yes, there is actually two main packages here with the topology optimization. And let me pull up a comparison here. All right, so here, this really comes down to how much are you doing? So in the base package, a given part can have 3 analysis, whereas in the plus package, you could have as many different types of concurrent analysis as you want. And then next we have types of analysis, so structural, modal, and then that's going to be considered in the normal, just standard topology optimization. And then you would utilize the plus package to see something like the thermal analysis. And finally, the fabrication constraints I mentioned earlier. So we have the most common ones included with just the base package, but there's a bunch of other ones that you can utilize in the plus package. So whatever your needs or requirements happen to be, we definitely have you covered.
Great, thank you so much. It looks like there are no more questions. So if you enjoyed this presentation, I highly encourage you to subscribe to our YouTube channel as we have previous Creo, MathCAD, and Windchill webinars and tutorials. Follow us on LinkedIn, Facebook, and Twitter as well to be updated on any upcoming events, webinars, and exclusive deals from PTC. Once again, thank you all for attending and have a great rest of your day.